Welcome to Study Loop.
12, problem number 67 from the Smith Organic Chemistry textbook. And this problem gives us this starting material that I've drawn here and asks us to get from this starting material to molecule A, which is pictured in the book. And basically, the way to approach a problem like this, a synthesis problem, we need to look at our starting material and look at molecule A, which needs to be our final product, and determine what's really changed. And so in regards to that, we have this alcohol in our starting material, and it looks like we've esterified that. So we have a 3-carbon chain with a methoxy ether on the other end. And then we also, in place of this aldehyde in our starting material, we have a bromide. So we need to change both of those things to get from our starting material to our product. And so we will first convert this alcohol to that ether. And so a straightforward way to do that is to deprotonate it with sodium hydride, which is a strong base. And so that's not going to affect anything else in this molecule. So our aldehyde is still there. The methoxide from the starting material is unaffected. And then here we'll have the deprotonated alcohol. So we can do that with dibromopropane. So BR 1, 2, 3, and then another BR. And that's going to give us this intermediate. Oops. So again, nothing else will be affected by that. But now here, 1, 2, 3, we now have our 3-carbon chain added. So we've made the 1 ether. And then we just need to replace that bromine at the end there with a methoxy ether. And so in order to do that, so the problem tells us we can use any organic alcohols or inorganic reagents that we want. And so we can just use a methoxide ion here. And if you feel the need to justify that, we could do methanol treated with more sodium hydride. Oop, too high. I'm just going to write it under the arrow. So methanol treated with more sodium hydride there is going to give us methoxide ion. So that's where we can justify that coming from. And so when we use this methoxide ion that we just generated, that's going to get us to here. So again, nothing else in this molecule should be affected. But here, 1, 2, 3, we are where we want to be. So there we go. So that takes care of the changes that we need to affect at that, what was the alcohol in our starting material. So now we need to deal with converting this aldehyde that we have into this bromide that we need in our final product. And so we can start, so the strategy is going to be to reduce the aldehyde and then to treat that reduced aldehyde, which would be an alcohol, with some PBr3, and then that's going to get us to our final product. And so there are a couple different things we could use to reduce this alcohol. So I think the written answer says lithium aluminum hydride. Lithium aluminum hydride is like using a sledgehammer. And so I'm gonna use a less reactive but still quite effective reagent, so sodium borohydride. So that's a good reducing agent for aldehydes and ketones. So that's going to get us to the alcohol here. And then nothing else about our molecule should have changed. And then when we treat this alcohol that we just made with phosphorus tribromide, PBr3, that is going to take us from that alcohol to the bromide, and that's going to be our final product. Oof. There we go. Okay, and so this is molecule A that we were asked to make. That's our final product. And so again, the way to approach a synthesis problem like this is to look at the starting material that we're given, look at the product, compare what has changed from the starting material to the desired product, and then figure out a way to affect those changes. And so in this case, we needed to convert an alcohol to an ether with an ether at the other end of the carbon chain as well. And then we needed to reduce an aldehyde and replace it with a bromide. And so that's the answer to chapter 12, problem number 67.